12.4 Cross Product Part 2. Given two non-zero vectors u and v in 2 or 3 dimensions, their cross product, written u cross v, is a vector with magnitude equal to the magnitude of u times the magnitude of v times the sine of the angle between u and v. The direction of the vector will be perpendicular to both u and v following the right-hand rule. At the end of Part 1, I promised you a convenient method for finding the cross product given the components of a and b. This method makes use of determinants. So let's have a short discussion about determinants. If A is a 2 by 2 matrix, then the determinant of A is AD minus BC. If A is a 3 by 3 matrix, then the determinant of A follows this formula. The first term is A times the determinant of the matrix found when you eliminate the row and column containing A. The second term is negative B times the determinant of the matrix found when you eliminate the row and column containing B. And the third term is C times the determinant of the matrix found when you eliminate the row and column containing C. The easiest thing to forget is the negative in front of the second term. So you might want to make a special note of that. Using the properties of cross products, we can find the cross product of u and v, but the method is pretty messy and time-consuming. An easier way is to use determinants. If we know the components of u and v, then u cross v is equal to the determinant of the matrix created in the following manner. The first row of the matrix is just ijk, the unit vectors. The second row must be the components of u, and the third row must be the components of v. So find that determinant and you will find the vector u cross v. So let's find the area of this triangle. Recall that the magnitude of the cross product is the area of the parallelogram given by the vectors u and v. So to find the area of the triangle, we will do the following. We will find the vector OP, then we will find the vector OQ. Then we will find the cross product OP cross OQ. Then we will find the magnitude of the cross product. The magnitude of the cross product gives us the area of the parallelogram defined by OP and OQ. Now we want the area of the triangle, so we will divide our result by 2. OP is 234 and OQ is 320. Next, I set up the determinant. Remember, the first row contains the coordinate unit vectors. The second row is the components of OP. The third row is the components of OQ. When you find the determinant, you should get the vector -8, 12, -5. Next, we need to find the magnitude of this vector. The square root of 8 squared plus 12 squared plus 5 squared is equal to the square root of 233. take that result and divide it by 2. The area of the triangle is about 7.63 square units. Find a vector normal or orthogonal to the two vectors u and v. Recall that the vectors a cross b and b cross a are both perpendicular to the plane containing a and b. We only need one normal, so we will find u cross v. U cross v is normal to the plane containing u and v. So all I need to do is find the u cross v using the determinant. Again, my first row is comprised of the coordinate unit vectors. The second row is the components of u, and the third row is components of v. Go ahead and find that determinant. And I get the vector 30, 9, 5. And that vector is perpendicular to both u and v. Let's do a little summary. We discussed a dot product in the last section, and in this section we discussed cross product. So let's do a little bit of comparing. Dot product, u dot v, cross product, u cross v. The dot product is a scalar value. The cross product is a vector. And remember, it's a vector orthogonal to both u and v. Now, u dot v is equal to the magnitude of u times the magnitude of v times the cosine of the angle in between. U cross v, remember, is a vector, but its magnitude is equal to the magnitude of u times the magnitude of v times the sine of the angle between u and v. The dot product discussion was motivated by the need to find work. The cross product discussion was motivated by needing to calculate torque. Take care, and I'll see you in the next section.